Hi everyone, welcome to Chemicals Academy. We discussed alkaline metals from JD Lee. Now we will move on to alkaline earth metals group 2 elements. So their properties, ionization, enthalpy order, the compounds formed, especially the organic metallic compounds, complexes and biological importance of magnesium and calcium will be discussed. So moving on to the topic, alkaline earth metals are beryllium, magnesium, calcium, strontium, barium and radium. So radium is a radioactive element and beryllium, the outer electronic configuration of beryllium is 2s2. So the last electron will enter into the 2s shell, 2s2, and for magnesium it is 3s2. For calcium 4s2 and for strontium it is 5s2, barium 6s2 and radium 7s2. So from moving down the group, the size increases. So down the group, size increases always. Size increases. And when we discuss group 1 element, lithium, sodium, the outer electronic configuration was for lithium, it was 2s1, for sodium 3s1 and so on. So in group 2 elements, the size increases down the group similarly like group 1 elements. And what about the ionization enthalpy? Ionization enthalpy is proportional to 1 by size. That means size increases, ionization enthalpy decreases. So beryllium having 2s2 configuration, removing one of the electron from 2s orbital is difficult. That means ionization enthalpy is greater. We need more energy to remove one of the electron from 2s2 subshell. So ionization enthalpy is greater for beryllium since size is small. Size small, ionization enthalpy greater. Ionization enthalpy greater. So ionization enthalpy order is beryllium having greater ionization enthalpy, then magnesium, then calcium, then strontium and barium. And what about the second ionization enthalpy? When first ionization enthalpy means to remove the first electron from the outermost shell. Once one electron has been removed, the ratio of charge of nucleus to orbital, ratio of charge of nucleus to nucleus to orbit will be greater. So nucleus to orbit will be greater. So the electron will be strongly held by the orbit. So electron is strongly held means it is difficult to remove this electron from the orbit. So ionization enthalpy will be greater. That means second ionization enthalpy is higher for group 2 element compared to group 1 element. And size of the group 2 element is small compared to group 1 element means ionization enthalpy will always larger for group 2 elements. So size small. Size is small compared to group 1 element. Group 1 element. And ionization enthalpy is larger for group 2 elements. So just remember size small, ionization enthalpy greater. Size is small, ionization enthalpy greater. So that's about ionization enthalpy order. Now moving to electronegativity. So these are metals. These are electropositive elements. So alkaline earth metals and alkali metals are electropositive. Positivity is greater. Electropositivity is greater. That means electronegativity is low. The electronegativity value is low for alkaline earth metals. So lower electronegativity values, But compared to group 1 elements, it have high value. When comparing group 1 elements, group 2 have high electronegativity than group 1. So generally low electronegativity value, but group 2 have high electronegativity value compared to group 1 atoms. Now hydration energy. So hydration, when talking about hydration energy, 4 or 5 times greater than group 1 ions. So 4 or 5 times greater than group 1 elements. So group 2 elements have high hydration energy compared to group 1 elements, and hydration energy decreases down the group. When you move from down the group, the size increases and hydration energy decreases. So hydration energy decreases when you move from top to bottom of the group. So that's about hydration energy. Next one is what? Solubility. So solubility is depending upon the atomic weight. Solubility is depending upon the atomic weight. The atomic weight increases, solubility decreases. Atomic weight increases, solubility decreases. So atomic weight increases, solubility decreases means beryllium, magnesium, calcium. So which is having higher atomic weight? Calcium is having higher atomic weight. So solubility will be low for calcium. Solubility will be low for calcium salt. And there is an exceptional case for solubility also, the fluorides and hydroxides. Fluoride and hydroxides have reverse order. That means for calcium salts, all other calcium salts, the solubility is low. But when coming to calcium fluoride or calcium hydroxide, the solubility is greater. So I will explain why this reverse order is coming. So there is two factors which depending upon the solubility. So what are the factors? Lattice energy and hydration energy. So for a salt, if lattice energy change, so there will be a change in lattice energy and hydration energy change. Change in lattice energy is greater. If the change in lattice energy is greater, then solubility is increased. Solubility is increased. And if hydration energy is changed larger, then solubility decreased. So change in hydration energy increases, solubility decreases. So why fluorides and hydroxides have high solubility? Their lattice energy is increasing. So the solubility is increasing. When lattice energy is increasing, solubility increasing, and when hydration energy changes increasing, solubility decreasing. And the lattice energy is depending upon the size. Lattice energy decreases when size increases. So beryllium, magnesium, calcium, so which is having high size? Calcium is having high size. So lattice energy will be low. Lattice energy will be low for calcium, and for beryllium lattice energy is high because size is small. So lattice energy similarly like ionization enthalpy, it is directly proportional to or inversely proportional to size, directly proportional to 1 by size. Most compounds on descending the group, the hydration energy decreases more rapidly than lattice energy. So when you move down the group, that is from beryllium, magnesium, calcium, strontium and barium down the group, the hydration energy changes decreased. Hydration energy changes increased. So the hydration energy change is coming into main role. So what happened? The solubility decreases. When hydration energy changes increased, the solubility decreased. So for beryllium, magnesium, calcium, strontium, barium, the barium is insoluble. But coming to fluoride and hydroxide, the compounds of barium hydroxide, barium fluoride or strontium fluoride, the hydration, not hydration energy, the lattice energy is coming into play. So when lattice energy is changing, the solubility is increased. So there is an exceptional case for fluorides and hydroxides, the solubility increases when lattice energy change increases, and for other salt the solubility is decreased only because the hydration energy changed. Now we can discuss the compounds formed by alkaline earth metals. That is, first one, hydroxide. So calcium hydroxide is formed when calcium plus water is reacted. Calcium hydroxide is formed. Similarly, all other hydroxide can be formed while reacting with the water. So when calcium is reacted with water, calcium hydroxide and hydrogen gas is evolved. And next one is beryllium plus NaOH. Beryllium, one more thing, beryllium is an exceptional case in this alkaline earth metals like lithium. So in group 1, lithium was an exceptional case. In group 2, beryllium is an exceptional case. In many properties, beryllium stand out. Beryllium have anomalous properties. So here beryllium plus sodium hydroxide will give a beryllium hydroxide, that is Na2 beryllium hydroxide, BOH 4 times plus H2. So this is an amphoteric hydroxide, amphoteric. And all other hydroxides are basic. All other hydroxides of calcium, strontium, magnesium, etc. are basic, but beryllium hydroxide is amphoteric. And next compound is oxide, normal oxide. So in group 1 elements we discussed the normal oxide, monoxide, superoxide, etc. Now in alkaline earth metal, normal oxides are formed. How this is formed? A metal, alkaline earth metal, 2 metal plus O2 give MO, 2MO. So this is a normal oxide. So for example, barium plus O2 give barium BaO2. So BaO2 is a normal oxide. So here 2 barium. So you can write 2 BaO. So this is a normal oxide. The important topic is hardness of water. Hardness of water. So what is hardness of water? There are two types of hardness, temporary hardness and permanent hardness. So the factor which affecting temporary hardness is what? Magnesium bicarbonate. So temporary hardness is due to magnesium bicarbonate, HCO3 twice, or calcium bicarbonate. So both are responsible for the hardness of water, magnesium and calcium ion. So magnesium bicarbonate is the reason for temporary hardness. And what is temporary hardness? It can be removed by boiling the water. So when you boil the water, the temporary hardness, magnesium bicarbonate, can be removed. And permanent hardness means permanent hardness. So permanent hardness cannot be removed by boiling the water. So permanent hardness is due to magnesium sulfate or calcium sulfate. So sulfate of magnesium and calcium is responsible for permanent hardness. Then talking about the sulfates of alkaline earth metals, beryllium sulfate and magnesium sulfate are soluble. Beryllium sulfate and magnesium sulfate are soluble, and calcium sulfate is sparingly soluble, and strontium, barium, radium are insoluble. So calcium sulfate is sparingly soluble, and beryllium sulfate and magnesium sulfate is soluble, and strontium, barium, radium sulfate are insoluble. This type of compounds are hydrides. So the general formula for hydride is MH2. How the hydrides are formed? The metals are reacted with H2. So you will get MH2, that is hydride. And BeH2, beryllium hydride, is difficult to prepare and it is less stable. It is less stable. So beryllium hydride is difficult to prepare. And how this can be prepared? 2BeCl2, beryllium chloride, is taken and it is reduced with lithium aluminium hydride. So when you reduce lithium aluminium hydride, when you reduce beryllium chloride with lithium aluminium hydride, you will get 2BeH2, beryllium hydride, plus lithium chloride plus AlCl3. So this is the reaction. Just remember this reaction. Beryllium hydride is obtained by reducing beryllium chloride with lithium aluminium hydride, and calcium hydride, strontium hydride, CaH2SrH2, that is strontium hydride, barium hydride, are formed when heating with hydrogen, and they are ionic. They are ionic compounds. And beryllium hydride, BeH2, and magnesium hydride, MgH2, are covalent. So the difference is calcium, strontium, barium hydrides are ionic, which contain H- ion. So that is ionic. And beryllium, magnesium hydrides are covalent and they can be in polymeric structure. So they can be in polymeric structure. Polymeric structure means BeH2 can be in polymeric structure means BeH2 n times. So 3 center 2 electron bonds are present. What is 3 center 2 electron bonds? The banana bonds. The banana bonds which is seen in boranes. So when you analyze the structure of borane, you can see a banana bond. Next is halide. So alkaline earth metal can form halide also. The general formula is MX2. So X means a halide, any type of halide, chlorine, bromine, iodine. M is metal and it is formed by heating metals with halogen. So anhydrous halides are polymeric. What is anhydrous halide of beryllium? BeCl2. So BeCl2 is anhydrous halide and it can be in polymeric structure, that is BeCl2 twice. So I already said polymeric structure can contain 3 center 2 electron bond. Then chloride, bromide, iodide of magnesium, calcium, strontium, barium are ionic. So magnesium, calcium, strontium and barium chloride and iodide bromide are ionic. These are ionic and they are lower melting point and boiling point. They have lower melting point and boiling point and these are soluble in water. So these are soluble in water also. Magnesium iodide or chloride, etc. And next one is nitride. So nitride, the general formula is what? M3N2. For nitride, the M3N2 is formed how? The metal is reacted with dinitrogen. M plus N2 will give M3N2 nitride. And one more thing, Be3N2, beryllium nitride, is a volatile. So beryllium nitride is a volatile and others are non-volatile. Others means magnesium, calcium, strontium, barium nitrates are non-volatile. Beryllium nitride is volatile. So I already said beryllium had different properties. It stands out in the alkaline earth metals. And calcium nitrate, Ca3N2, calcium nitrate is formed and calcium nitrate is reacted with water, H2O, you will get calcium hydroxide. So when calcium nitrate is reacted with water, you will get calcium hydroxide. So there are chances to ask these reactions. So in one question, one year, a question was asked about the group 1 metals, how the oxides are formed with lithium. So how the oxide is formed? Li plus O2 will give LiO, that is a oxide. So similarly these type of reactions can be asked as question. Next class of compound is carbide. Carbide. So what is the formula for carbide? Mc. So carbide means Be2C. Be2C. Beryllium carbide is a brick red colored carbide. Brick red color carbide. And BeO, beryllium oxide, is heated with carbon to form Be2C, beryllium carbide. So BeO is heated with carbon to form beryllium carbide, and it is a ionic carbide. It is a ionic carbide. And magnesium, calcium, strontium, barium form carbides of formula Mc2. So in beryllium carbide, the formula is Be2C, that is M2C. And for other magnesium, calcium, strontium and barium, the carbide formula is Mc2. So that means MgC2, not Be2C, not Mg2C. It is Mc2. So that's the difference. In beryllium, the carbide formula is Be2C, and in magnesium, calcium, strontium, barium, radium, Mc2 is the formula of carbide. And another important point to remember is calcium carbide. So what is the formula of calcium carbide? Mc2, that means CaC2. CaC2. Calcium carbide is heated with nitrogen. So what happened? CaC2 plus N2 will form CaNCN. CaNCN plus C. So CaNCN is what? Calcium cyanamide. So cyanamide is formed. Cyanamide means N double bond C double bond N 2 minus. Cyanamide ion is formed. N double bond C double bond N 2 minus. And it is isoelectronic with carbon dioxide. So this has same electrons as carbon dioxide. So it is isoelectronic. So there is a chance to ask cyanamide is isoelectronic with CO2. And when barium nitride, that is barium carbide, BaC2. When barium carbide is reacted with N2, there is not forming cyanamide, but instead of cyanamide, what is forming? BaCN twice. Cyanide. BaCN twice is formed when barium carbide is reacted with dinitrogen. So carbides formula is M2C for beryllium and Mc2 for other Mgs, calcium, strontium, barium, etc. Now coming to organometallic compounds formed by alkali metal. Organometallic compounds. So the important organometallic compound is Grignard reagent. So the general formula of Grignard reagent, how to prepare? Magnesium plus RBr. R can be alkyl or aryl group in presence of either dry ether. So in presence of dry ether, magnesium plus RBr is heated. So what happened? RMgBr. So this is Grignard reagent, RMgBr. And one important point is iodides are most reactive. Iodide. So instead of bromine, if iodide is there, it is highly reactive. And chlorine is least reactive. And alkyl, if R is alkyl, then it is highly reactive than aryl. Highly reactive. So if R is alkyl, then it is highly reactive than aryl group. So R should be alkyl group, and if instead of bromine you can take iodine also, it will be highly reactive. So the reactions of Grignard reagents are 2RMgBr plus water. So what you will get? 2RH, a hydrocarbon, plus magnesium hydroxide, MgOH twice, plus magnesium bromide, MgBr2. So a hydrocarbon is formed when Grignard reagent is reacted with water. So that's one reaction, and so many reactions are there with the Grignard reagent. When Grignard reagent is treated with carbon dioxide, so RMgBr plus CO2 in presence of a acid, what you will get? a carboxylic acid, RCOH. Moving on to biological importance. So biological importance of alkaline earth metals, that is mainly magnesium and calcium. So we will talk about magnesium 2 plus and calcium 2 plus biological importance. So magnesium 2 plus is present in animal cell. It is present in animal cells, and calcium 2 plus is seen in body fluid. So it is outside the cell, body fluid. So it is same like the sodium and potassium, sodium and potassium salt, same like sodium and potassium salt, that is the concentration in outside and inside cells. So magnesium is inside animal cells and calcium is inside body fluid, that is outside the cells. And magnesium 2 plus, the major complex formed by magnesium 2 plus is chlorophyll. So it is the main important complex. Chlorophyll contain magnesium 2 plus, and calcium 2 plus is present in bond, should be present in bonds, teeth, etc. So in bonds and teeth, calcium 2 plus is present, and in teeth it is formed in apatite, that is the formula is Ca3PO4 twice. Ca3PO4 twice. And in enamel on teeth it is fluorapatite. Another uses of calcium 2 plus is it is important for blood clotting and required to trigger contraction of muscles. So for contraction of muscles, the calcium 2 plus is required to maintain regular beating of heart. So beating of heart to trigger contraction of muscles. For blood clotting, calcium 2 plus plays an important role. So the biological importance of magnesium and calcium is what? Magnesium is present in chlorophyll and it is in animal cells. Calcium is in body fluid and it helps the strength of bones, teeth, the enamel of teeth, and it is fluorapatite in enamel of teeth.